Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And in this short video, another video in our series of videos dealing with non-parametric statistics, and in particular correlation coefficients, is going to concentrate on what's known as the point-Biserial correlation, which effectively is a technique for calculating the strength of association or the correlation between a dichotomous variable and an interval stroke ratio scaled measurement variable that's measured on an interval stroke ratio scale. It's important here in relation to the point-Biserial correlation that the dichotomous variable is, I suppose, it's nominal. It's not ordinal, it's nominal. So for example, gender is an example of a nominal variable. It's dichotomous in the sense that we're only considering males and females. Spending behavior is an interval stroke ratio scale variable. The biserial correlation, which is an alternative technique, can be used when we have what's known as a continuous dichotomous variable. This variable here is a discrete dichotomous variable. We could have a continuous dichotomous variable, in which case the variable has two categories, but there's a natural order, so they're measured on an ordinal scale effectively. But in this situation, we want to see whether there's an association between the gender and spending behavior of individuals. And to calculate this statistic is actually quite straightforward. The correlation coefficient PB, point-Biserial, is simply equal to the average of the we're going to have two groups. We're going to call the first group P. Okay, so you can start to see here is the first group P, and here's the second group. The groups are defined by the dichotomous variable. We call that Q. So XP is the average on the interval ratio variable, okay, for the first group, minus the average on the interval ratio variable on the second group, divided by the standard deviation, okay, for the whole variable, okay, for the interval variable, and that's multiplied by the product or the root of the ratio or the proportion of observations in the first group. So proportion of P times the proportion of observations in the second group. Okay, so it's actually quite straightforward to calculate. We're actually just calculating three mean values, and we're calculating a standard deviation. So just to calculate the mean values themselves, if we have a look at, I'm just looking for, there's my calculator here. Okay, so let's just calculate first of all. Let XP. X bar P is the average for the males, and I'll just write this out in detail. It's 12 plus 8 plus 7 divided by 3. That's 27 divided by 3. So we have 27 divided by 3 is going to give us the average is equal to, I should have known that, that's just average is equal to 9. Then we have X bar of the second group of Q is going to be equal to, well, the four observations in here are 22, 18 plus 16 plus 20, okay, and that's going to be divided by 4 this time. So what have we got? We have 22 plus 18 plus 16 plus 20, divide that by 4, gives us a value of 19. So the average of the first group, which are males, is 9. The average of the second group, females, is 19. So we have the XP, and we have the X bar P, and we have the X bar Q. What about the proportion of P? In total there are 1, 2, 3, 4, 5, 6, 7. In total, there are 7 observations. Okay, so there's 7 observations in total. So n is equal to 7. The proportion that are associated with the first group P is basically, well, we have 3. It's 3 over 7. The proportion associated with the second group, well, there's 4 of them. It's 4 over 7. So in this situation here, we have 3 divided by 7 gives us a value of, let's say, to 2 decimals, 0.43, and 4 divided by 7 gives us a value of, in this case, let's say 0.57 to 2 decimals. So we effectively have everything. We have XP, we have X bar P, X bar Q, we have PP and PQ for the two proportions. The only thing that we're missing is the standard deviation of the overall group. So let's do that. So we have to calculate X bar for the variable, for the interval variable, okay, well, it's equal to the summation of all of these values. So let's just sum up them values there. What have we got? We have 20, we have 40, we have 49, we have 59, 69, 71, 79. I'll just do it on the calculator. I think I probably made a mistake there. 12 plus 8 plus 7 plus 22 plus 18 plus 16 plus 20, just so that I'm really sure of what we have. So the summation of them is 103. So the overall x bar is 103 divided by how many observations we have, which is 7 observations. So when I divide that by 7, that gives me, so I have 103 divided by 7 gives us an average of 14.71. So it's 14.71. So to calculate the standard deviation of these, well, let's do the sum of squares. So it's x minus x bar to be squared. So for each observation, we're going to take away the mean, which is 14.71, and we're going to square it. So it's 12 minus 14.71 squared gives us a value of 7.3441. We have 8 minus 14.71 squared, that gives us a value of 45.0241. We have